Okay, we are back. So, second video here, and this one will be hopefully much shorter. We're just going to keep cranking out problems, okay? So, the last video we were cranking out uh, linear examples. In other words, the highest power was 1. And when the power goes up, things get a little bit more trickier. So, trying to do things that are quadratic just means the power is, well, the second degree, like this right there. See, yep. So if that's what you're being asked to do, solve that function. It's really no different than a quadratic function. It's just sometimes you're gonna have to do quadratic things to it. So if I took that and I added the 1 to the other side, you're gonna end up with 2 sine. Whoa, I wonder how that happened. I think there's a ghost on the computer. So let's just go ahead and be patient. We'll start over again. 2 sine squared theta equals 1. And on top of that, what we're going to do is we're going to divide both sides by 2. Then you get sine squared of some angle theta equals 1/2. Square root both sides, and you end up with sine of theta is equaling to plus or minus. Well, if we do it the right way, we have 1 over square root of 2. Rationalize the top and bottom. So sine theta is really going to equal square root of 2 plus or minus over 2. So in other words, what the question has now become is they want to know the angle that you need to plug in to get out that ratio, root 2 over 2. And you should be telling me, well, here's your unit circle. I know my chart, my 2 circles, Mr. J. This is 45 degrees. And let's do this one in degrees. That's okay. Remember, again, my limitations. I know I keep saying it, but I got to make sure that you understand that we all get the first answer together. And so inverse sine of root 2 over 2 would be, if I want the first answer, would be either positive 45 degrees or inverse sine of minus root 2 over 2. Remember, you got to handle the plus or the minus option, is minus 45 degrees. Okay? So that's all fine and dandy. However, remember I told you the most important part, the angles that they're going to allow you to submit for answers. So really, the only angles you can submit are angles that give you root 2 over 2, positive or negative. Now notice there's 4 times that occurs. So the reference angle every time is going to be 45 degrees. But hopefully what you're seeing to yourself is, hey, you can get to this spot a different way if you rotate all the way around, right? So if you rotate all the way around, I think that's 315. So here we go. So this is 45 degrees here. That's one answer. And 135 to here, to that spot. And then if I rotate all the way around to the third spot, 225. Do you get it? So those 4 rotations of 45 degrees, 135, 225, and 315 will allow you to get to the spots where you either have this ratio for sine. So you just have to label that in your final answer. So angle is going to be 45 degrees, or you could say pi over 4, 135, or 3 pi over 4. And it helps sometimes if you do both versions. It'll get you good at um, being able to do it either way. That way you're not, dependent upon degrees or radians or trying to convert all the time. That'd be 7 pi over 4. Okay, so theta 1, theta 2, theta 3, get it? So you have 4 angles here in degrees or radians. Again, if you're not asked to choose, usually the default is always radians. But if no one says, if you do your angles, that'll be okay too. Or your angles, I mean degrees. Now, next one. Let's choose a different color. I'm tired of blue. We have another quadratic function, and a lot of times it might help if you don't look at the trig functions and just use substitution. In other words, if you had that, and notice all I did was replaced x with whatever sign was there. So I let sine equal x, so I had 2x squared minus 5x plus minus 3. And really, you might then be inclined to factor that thing out. So everything that you used to do with quadratics in Algebra 2 and other classes, you can still do here. And if that's a -3 and this is, well, that's not going to work. -3 there as I'm talking myself through this. So it's -3 and this is a +1. Then you have two new functions, right? Now, notice what I'll do at this point. I'll replace the sine function back in for x. So you can either use x and then replace it back or just do sine to begin with, whatever you're comfortable with. But again, I am foiling or reverse foiling or factoring that thing out, and then going to use the zero product rule to say either 2 sine theta plus 1 equals 0, minus 1, 2 sine theta has to equal -1. So sine, here we go with that half again, -1/2, right? Or sine of theta minus 3 has to equal 0. And we can finish up and say sine of theta has to equal 3. And just like a couple examples before, there's no angle. Remember, we can only get, our range of answers has to be from -1 to 1. So there's no angle where I can even get 3, so I toss this. So for that part, there's no solution. However, and I'm going to cheat on this one, you want the angle that's going to get you -1/2. So sine of one angle gets you -1/2. Let's go up here. My computer wanted to have a mind of its own earlier and come up here anyway. So remember, keep referring to this and just keep using the same problem because that way we don't have to keep working at the same thing over and over. But remember, we started out here, where inverse sine of -1/2, and we went down 30 degrees. That's how we got this. Or down minus pi over 2, or pi over 6. However, that was not and is not the range of answers this time. It is, remember, if I'm going around the circle, and I keep doing this circle over and over, I'm only going to get to here. Or as I keep going to here, that gives me -1/2. So here, or if I keep going to here. And if I'm looking at my angles again, that was time 1 and time 2, or 7 pi over 6 and 11 pi over 6. So if you don't remember that, go back to that first video. It's one of the first problems we did. But so in this case, theta is going to equal 7 pi over 6, or theta has to equal 11 pi over 6. And again, I'm putting those two answers because the most important part of the problem is where they want all the angles in between. So in this case, including 0 all the way up to including 2 pi. Okay? Now, I laid off writing this the perfect way, but again, you should always write it so that your instructors in the future are I know, or the math people in the math world that you're going to encounter know that you're stating, hey, I'm going to take in the ratio and I'm looking for the angle. Okay? Okay, so your turn. We're going to do one more here and we'll cut this video off. Solve that equation from 0 to 2 pi. Notice that's the important part. Bubble that up right off the bat. Of sine squared equals all that. Pause the video. I'll give you a hint. You might want to do a substitution right off the bat. See if I do this for you. I'm going to move the cosine squared over and just see if you can figure something out. Why would I share this with you? That's one of those other formulas. But pause the video, see if you can do that. They're trying to solve the equation from 0 to 2 pi. Go for it. Okay, if you're back, the reason I showed you this, that sine squared equals 1 minus cosine squared theta, was because I was trying to encourage you to substitute that in for, let's erase this now, sine squared theta. So sine squared theta equals that quantity. It's much easier to solve these equations when you're only dealing with one, either all cosines or all sines or all tangents. But as soon as you start bouncing between sines and cosines, life gets tougher. So hint, hint, try to get all one trig operator if you can. And once you have that all in, I'm going to move all of this stuff to the right, which is going to yield 0 on the left side. And I'm going to have a positive cosine squared theta. That's just this, that got moved this way. And then I'm going to put this there. So what, plus 2 cosine theta? And then when I take this 1 and subtract that from the 2, plus 1. And at that point, again, because we have a quadratic scenario here, you can FOIL that out. Put cosine times cosine. It's going to give you this first term. And probably a 1 here and a 1 here. You don't have much of an option because 1 and 1 multiplied together, you have to give you that. And turns out if you do that and you FOIL that out, you'll get this quantity right here. That's what we started with. And now you have two of the same thing, so you only have to do it once. But off to the side here, let's go ahead and do it. Cosine of theta equals plus 1, excuse me. Or cosine of theta equals negative 1. An inverse cosine gives me what angle? What angle am I looking for? In other words, what angle will give me negative 1? And on a unit circle again. That's this spot. We keep hitting the same spots, and that's just kind of done intentionally. So that part there is not not mystifying. But again, there's 3 more problems, and in the next video, I think I'm going to come back and do about 3 more for you. So good job. Practice those and try the next 3, and then watch the next video.